Tonight's talk is titled Towards Efficient AI, the Mechanics and Real World Impact of Model Distillation. In short, how do we make the knowledge from massive AI models and compress it into smaller, faster ones we can actually deploy? Tonight covers how it works, when to use it, and when not to, with real case studies and live demos. And in this talk, it's open to beginners and to advanced people. Now, please meet our speaker for tonight. He is an undergraduate software engineering student at FU Institute of Technology, specializing in AI research, with hands-on experience in model distillation. His work focuses on vision language models and parameter-efficient fine-tuning for real-world deployment. He also serves as the project manager and lead developer of a dedicated research team where he brings a rigorous human-centric approach to AI evaluation. Everyone, please give a warm welcome to Jules. Take it over, Jules.
All right. Good evening, everyone. First question. Can you guys see my presentation? I need to confirm first before we begin. Yes, okay. Okay, so I guess we can start now. Ay, minimize po. Hindi pa. Oh, okay, wait lang. Stop swimming. Oh, wait, let me try again. Wait. I guess I shared the wrong. Okay. Okay. Uh, okay, can it be seen now? I guess it can be seen. Is it moving? Uh, yes, okay. Okay, so I guess we will be having a discussion in model distillation. This presentation and talk will be mostly focused on the beginner side of things. So I try to make it as comprehensive and simple as possible while still giving a comprehensive understanding of what we are exactly dealing with. Now, this is the title, Towards Efficient AI, the Mechanics and Real-World Impact of Model Distillation. Now, I'll give you guys 1 minute to scan the QR code for the presentation. You guys can see the QR code and you guys are able to scan it, right? Okay, I'll start counting for 1 minute. Can you send the image? Wait. Okay. Hmm. Okay. Okay, I gotta try again. Still not loading screen. Um, can it be seen now? Okay. How about now? Okay. So I won't be working with a presenter's view for this talk. Um, I'll wait another 30 seconds for more scanning since there was a delay in presenting the presentation in question. Okay. Okay, so the 30 seconds are up. I think we can start now. Now, now to outline on what we'll be exactly dealing with, We will understand the core concept of distillation, the rationale behind distillation, when to do distillation, its mechanics, and how to do it for LLM distillations, and the impact that and impactful projects, and the datasets used or any dataset that we wish to feature, and the current challenges of model distillation. All right, let's begin. What is distillation exactly? We first find out about what distillation is exactly in our elementary days as the increasing of potency by reducing certain substances. So, so we are applying the same concept of distillation in computer science, where we reduce certain parts of a model to be more specialized. But it is not the same as I'm just boiling a substance and making it more potent. What we are exactly dealing with is that we have two things to understand. We have a teacher model, a model that's typically larger and typically billions and billions in parameters. A smaller model known as the student model, where it is taught by the teacher model for a particular task. It is smaller, compact, and hardware friendly compared to the teacher model. Okay, as to visualize as to exactly what model distillation is, I'll be citing Mohi et al. You have this larger teacher model, and we transfer its knowledge to a smaller student model with the same data seen by both the teacher and student model. Now, what is the rationale behind model distillation? Okay, let's look at these models in question. There's DeepSeek V4 Pro, which is 862 billions in parameters, GLM 5.2 with 753 billion parameters, the Quen 3.5 model with a 397 billion parameters, and Claude Opus 4.8 and GPT 5.5. Now, what all of these models have in common is the fact that they need large data centers to be running, looking by the parameter size. So in terms of hardware and compute, you really need a lot of resources to run these models, both closed source and open source. So what are the bottlenecks in large model architectures? Although I want to say that it's very obvious, it has to be stated. It's large, it's generalist in nature. I'm once again reiterating that it needs data centers. And we want to ask the question, do I really need billions in compute for a particular task? The answer is very obvious. And the principles of model distillation are the things that we consider as software engineers or AI scientists. We want to have a balanced inference speed. We want to consider the hardware constraints, the task at hand, the output quality, and the development time for these models. So when do we do distillation? Now, as to say for inference speed, like for chatbots, you don't really need real-time inference, but you do need acceptable inference for chatting, i.e. maybe 5 to 10 seconds for a response from a model. But for, let's just say for an object detection model, real time is a must. All right, that's one thing to consider. Now, how about the hardware constraints? For a particular task, do I really need a cluster of many GPUs, or do I just need one single GPU for a particular task? We all know for a fact that cheaper is often better. So we often choose the cheaper option. And that's why we do model distillation in the first place. Now, let's look at a particular case. For a Quen 3 VL4B model, do I need an A100 for it, or does an L4 work fine? From my own experience, the L4 is often enough. Sometimes T4 is even enough for this particular task at hand. The task requirements. What is this AI for exactly? If the model is required to be a generalist, then ignore. Generally, if you want a generalist model, it has to be really large. Now, what are we using this particular model for? Is it for software engineering? coding, building websites, classification, math, the possibility is often endless. And distillation works really well for task-specific models. Now, the output quality. We often choose a smaller model to fit our purpose, but does it hold to standards? Is it responding in the way that we intended it to? Did it learn well? Is it spouting quality responses or garbage? Why do we ask these questions? Because there is a risk to distillation, and that is noise. We will get into that noise by the end of this presentation. I want to discuss on what that noise exactly is. And lastly, the biggest factor to consider is development time. Distillation isn't really a replacement for human labeled data. If you're able to create a data set from scratch and you have the time, then do human labeling. It is the best. It is often the best. If not, then you must distill. Now, let us begin with the mechanics and methods of model distillation. We have the first type to consider, which is the response-based distillation. Essentially, the student simply focuses on copying the final output. It does not know how it got to that conclusion or what processes that it took the teacher. Like, think of it like just a student memorizing the answer key for an exam and never bother studying for how to exactly solve a problem. It just knows that 5 plus 5 is equal to 10. It does not know the reason behind why 5 plus 5 is equal to 10. It just memorized that it's 10. Now, let's try to visualize it. Now, we have an input data. What it essentially ignores is this internal and feature reasoning process and just focuses on the final output. Okay? And the response is simply aligned in that final output. No internal features or internal reasoning process, no chain of thought, no trying to understand how the teacher got to that method. The answer, that's all it wants, just the answer. Now, what is exactly the most common type of feature of distillation that we know of? It's actually the feature-based distillation. This is what most researchers, most computer science students, and this is the most common paradigm actually. For earlier, we just talked about the fact that it memorizes the teacher's answer. Now, for feature-based distillation, the student actually copies the process or it tries to understand the process on how the teacher got that final output. So instead of just memorizing the answer, it tries to study the reasoning process of the teacher in question. Now, this one's quite different, which is the relation-based distillation. Now, I want and I have a scenario. We know for a fact that in an embedding space, the points for dog and wolf are really close to each other, like they're right next to each other. Now, what is the point of a car in an embedding space? Obviously, it's going to be far away from the dog and wolf. Now, how does the student learn exactly? How does the student learn exactly? How the teacher categorized or placed the teacher, or how the teacher placed it. So essentially, this is what we're doing with relation-based distillation. So dog and wolf are close to each other, but car is far, and we want the student to copy that dog and wolf is close to each other and car is far away. And this is for their own respective embedding space or knowledge space in question. So this is the process. You have two inputs, A and B. It checks the internal features and it checks the relational distance. And we want the student model to simply copy the teacher in terms of how it places the objects it's in its own knowledge space. Okay, now how do we do modern LLM distillation? What I'm going to feature here is actually the feature-based distillation because it is the most common method that we deal with most of the time. Okay. First, let's start with the input data. For LLMs, it's just going to be the prompting that we do most of the time. Like it could be anything. But for my example, we want something that creates websites for us. Like here are some examples. Design a responsive landing page, create a front-end HTML CSS template, generate a single page, code an e-commerce product detail page, build a clean and readable blog post. Each of these is always going to be specific for a particular task. So for our task, it's website building. So the first step is just okay, we're going to do prompting. Now the internal feature and reasoning process. What do we want from the teacher model? Okay, we have prompted the task in question. Design a responsive landing page for an artisanal coffee shop featuring a hero banner, I mean news section and a contact form. So the teacher model reasons out, okay, I want to build the hero banner section at the top of the page. It should include full height, video. Or another type of reasoning, design the menu section below the hero banner, use the SS grid or flexbox to create a layout. Okay? So essentially, we're looking at the teacher's reasoning as to its process on getting the output. And the final probability output or the final output in question is simply the code snippet. And this is where we want to show the output that the student is expected to learn. Okay? Now the last part is that store it as an entry for a data set. You want to store the input data, which is your opening prompt, the internal features and reasoning of the teacher, and the final output, which is the code snippet. And the last part is use any fine-tuning method. You could do full fine-tuning, but we don't often do that because that's computationally heavy. We're probably going to use a fine-tuning method of any LoRa variant. It could be the original low-rank adaptation by Edward Hu and his team at Microsoft Research, or it could be the other types of low-rank adaptation, which is rank stable LoRa and decomposed low-rank adaptation. You could try testing which fine-tuning method works well for your large language model. Now, here are some impactful model distillation projects. Okay, I want to feature DistillBERT. Okay. The original the original BERT model is 200 million parameters in terms of size, and DistillBERT is only 67 million parameters in size. But in the but results show that the DistillBERT, although it does not perform as great as the original BERT-based model, it performs just as well for certain kinds of tasks. And we can see it from the table. So according to the team that made DistillBERT retains 97% of BERT's performance. Okay? And sometimes it is comparable. Now I want to feature the person that I consider my mentor on his thesis in question, because his thesis actually uses the multimodal capability of Gemini to train a custom VLM called Visual Quen for the identification of sludge content. And he is able to train this custom VLM with resounding results as to finding sludge content in short form social media. Now, as to feature my own work, which is inspired by his work, for my work, what I did is that I distilled the Gemma 431 BIT model, which was Google's most recent model of the Gemma family series, which is an open source model. Now, it is used to train the Qwen3 VL4B model for identification of scam content in YouTube and TikTok. And here are the results. Obviously, the base model has been improved with by fine-tuning it on this new data set in question, or the fact that we simply, yeah, we simply made it better through distillation. Now, here are some distillation data sets that I want to showcase. Now, this is the Alpaca training data set by Stanford University, in which they distilled the Text Da Vinci model by OpenAI to train the Llama 7 billion by Meta. Another one that I would like to showcase is the Share GPT training dataset. But this is for multimodal instruction tuning, wherein they made a lot of prompts for GPT-4 vision, and that's what they use to train Share GPT-4 V. Now, as for Alpha's work, which features the sludge dataset, it contains essentially 2,000 sludge and non-sludge features generated by Google Gemini's 2.5 Flash. Oh, I do want to point out something. Distillation is often better with a human verifier because there will always be a degree of noise in distillation, and human verification often lessens that. So if you're going to distill models, if you have the time to do human in the loop, I suggest you do that. Now, if you guys want to see the data set that I've worked on with my research, you can go to Kaggle and search this particular data set. It's similar to Alpha's, which is a 2,000 scam and non-scam features generated by Google's Gemini 4 31 BIT, and in some capacity, the previous Gemini 3 Flash model. Now, what are the challenges in model distillation? One thing that is always going to be a challenge in model distillation is the capacity gap. There is always going to be a physical limit to a student model's architecture, where knowledge transfer will often fail or will fail, or simply that the more complex a task is, the student model will always underfit. Maybe because it lacks parameters or it does not have enough layers. Simply put it, the student does not have enough brain cells to learn from the teacher. And that is a gap that can only be solved by increasing the student's parameter size or layers, or somehow improve the student model's architecture. Now, error propagation. Okay. So what does this mean exactly? We know for a fact that models, large language models, have some sort of bias in a given area. And when the teacher teaches the student model, the student model often copies the biases from the teacher. If the teacher is biased, so is the student. Essentially, the student has a blind faith in the teacher. Like, the student becomes a yes man, and the student believes the teacher is always right. And that is a problem. And how you can mitigate it is by diversifying your data set. And the last one, which is rather recent, and something I want to point out is company gatekeeping. gatekeeping. It is currently the most restrictive barrier in modern model distillation. As for example, Anthropic is not very thrilled about certain people or companies distilling their models. Or open there was even a dispute between OpenAI between with DeepSeek and ByteDance, where OpenAI accuses DeepSeek and ByteDance of distilling their GPT models to train the models of DeepSeek and ByteDance. And as for the references, um, it's here. You guys can open it. You can open it to check whether or not what I'm saying is true, and it can be verified. And thank you. That is the end of our presentation. Although the presentation is quite short, I do hope it is comprehensive enough and understandable. And we can begin our question and answer session.
All right, thank you so much, Jules. That was a great session taking us from how distillation actually works all the way to real projects and challenges you'll hit in practice. Now we're opening the floor for Q&A to our participants. Please drop your questions in the chat box, whether it's about teacher and student models, fine-tuning methods, or maybe even Jules' own research on ScamQuinn. This is your chance. So please drop them in the chat box as I read them and ask them to Jules. So any coding
Any
examples?
coding example?
Take it away, Jules.
Any coding examples? Hmm. I don't have any coding examples for this, but for right now, because I have not uploaded it to GitHub yet. But do message me about this. What I want to show is the high level representation on how you can do model distillation in particular.
Okay, for that, Jules. Actually, I have a question of my own that I'd like to ask you.
Okay,
So you mentioned
okay, go.
earlier the Anthropic issue with certain companies. I'd like to get your insights on this. Like, is it unethical or is it even like legal? Is it illegal to do this kind of attack? In what I know is called a distillation attack. What are your insights on this?
In regards to that, in my opinion, if you pay for the service, I guess it's not illegal. I guess it's a gray zone. Currently, Anthropic has a policy, but it's not to say that it's illegal. It's just against company policy. They can ban those accounts that's doing the distillation attack. But to me, it's perfectly fine as you're still paying for the service in question. Well, that's my opinion. Yeah, I agree with Drummer here. These AI companies do commit so many copyright distillations. So think of it like a Robin Hood situation. These AI companies steal your data, so we steal data back from them. Now, Drummer says here, if you send, yes. If you synthesize dataset using a teacher model and do SFT training, is that a feature distillation or a response-based distillation? Okay. It can be either both, actually. If you're not going to add the teacher's internal reasoning, then it's going to be a response base, as in build okay, I want you to build me a website. Let's just say make me a web page. That's your input data, and then your output is just the code snippet. So what's internal reasoning? Yeah. Is it logits? Actually, yes, it's logits. It's logits. It could be, yeah, it's logits. Because the internal reasoning, okay. Although I've represented the internal reasoning as text, we know for a fact that in transformer architectures, those are Those are matrices. Those are numbers. Any more questions?
Oh, so guys, if you have any more questions, please drop them in the chat box. If you want to get the slides, I also drop them. So scroll back a bit and explore. Oh, I see some people typing in. Okay, people typing in. I guess I'd like to ask something. So you mentioned distillation. Um, how, how does it go? How can distillation be implemented, or is it possible to distill via, in so we can distill by text, copy the teacher's response, but that's in text. How about images or videos or audio? Can we distill in a multimodal fashion? Do you have any insights on this?
Yeah, you can actually do that. In terms of distilling images, here's what you can do. Yeah, it also really depends on what is the input in question. So, for example, we're dealing with a VLM. You have a video. You have a video, right? If I recall correctly, okay, you have a video, and let's just say you want to classify that video. Um, you j- you really just need input and output for distillation. Like, it's there. You just need an input and you need an output that the student needs to learn. Like, it's no different from normal training or fine tuning. The only difference is that you're captioning or labeling data via models.
I see. Thank you for that answer. Okay, guys. And here's a question from the chat box from Pepito. And how do you know your distillation is correct?
How do you know if your distillation is correct? You do you do it okay. We know for a fact that there's going to be, yeah, it's benchmarks. Train test split, benchmarks. If there's an improvement or if there's an improvement, distillation definitely work. Yeah, distillation is mostly recommended for training. Yes, that's correct. I agree with the Pilipinas.
Okay, people are still typing their questions. I'd like to ask a question for myself. Regarding distillation as well, to break the ice a bit. Um, so what what do you think of distilling US models like Claude and Codex versus distilling Chinese models like Quen or Nimax or even European models like Mistral? What do you think is the difference in distilling between all of these different models from different regions? Is one better than the other, or um, are there biases that we inherit, or what? What are the implications of distilling, or are there any improvements in distilling from all of them to not be biased? Is being not biased even a thing? What do you think, Jules?
Um, in terms of distilling US models, it's very difficult. Like you need to set up complex pipelines for that as they have security in place. Like they don't want people distilling it. That's why Anthropic and OpenAI seems to be really complaining about, you know, certain companies and certain people distilling their models. Now, as for distilling uh, open source or Chinese models, it's really easy because you can download those models and you can run them yourselves, or you can go to Open Router and you just make API calls. One reason, one reason as to why I kind of like Google, it's because you can actually freely distill them. Like you can go to Google AI Studio and you can you can start distilling their latest Gemma 4 models. Even Gemini itself, you can be distilled. Same deal with US models though. You can generate 100k examples with Opus on Open Router. Ah, that's correct. That's correct. Ah, wait, same deal with you. You can generate with Opus on Open Router. When we talk about it's harder to do distilling on US models, we're talking about creating your own custom pipeline for that. Yeah, I guess you can use Open Router to distill Cloud Opus. Open Router made it easy for everyone to distill them. Quen is difficult. I have to disagree on this one. Quen or a Minstrel model, if you have the hardware and capacity, you can fine-tune them, you can train them. I mean, they're open source. Oh, I do have a question for Drummer. Why do you find Quen difficult to fine-tune?
Okay, seems like we have a response to Jules's question of why Quen is difficult to fine tune. Drummer said that that the malleability is not as good as Mistral and you need a larger batch, higher learning rate, and Quen is generally brittle due to overtraining. As opposed to Mistral, you can get away with a smaller batch size and smaller learning rate, which means less data required, less hardware required. What do you think of that, Jules?
Hmm, that's actually an interesting insight. I I guess we go back to the principle of trying to understand what we're working with exactly and is it within our capacity. For my projects, we used Quen 3VL as opposed to the other models like Gemma 3 or Ministral. It's because it's the most powerful in terms of multimodal reasoning. Okay, that's why we opted to choose the Quen model. But I I guess if what Drummer is saying is that I guess Quen is generally brittle during okay, I can easily be overtrained. I do agree on that part because I don't know how many times I've actually trying to find the perfect recipe for Quen. It is indeed difficult. If I recall correctly, I had to borrow Alpha's Age 100 GPU just to keep testing and fine-tuning the Qwen3VL model. Yeah, well, that's when I was starting, okay? And I am very thankful for. Yes, it's very expensive. I think I used $30 worth of his Nibius.
Okay. Another question from Oxesis. Parang medyo maraming distilled models na available sa Hugging Face. Do I have to be cautious or worry in choosing models? Or should I just stick with running Qwen 3.6 versus a model named Quentos?
Ah, oh, those models are essentially those Quetos. So that's a Quen model that's trained using responses from Fable 5, since that's the one that's currently available. But I don't know the particulars on how accessible Mythos is. I know for a fact that they're the same base model, and Quetos is just trained from that same model. Quentos is a hype model. Hmm. What? It's a scam. Hmm, that's an interesting insight. Why do you think it is a scam drummer? I want to know. Yes, that is true. That is true. There is indeed a gap capacity. That is one of the bottlenecks that we have mentioned earlier, which is the gap capacity gap. So yeah, I agree on that. But it won't stop people from trying to do that. I guess what Quentos does, yeah, the reasoning traces aren't even visible. Yeah, you have to try and for. I do not know the techniques exactly on how we can trace the reasoning. I guess you can prompt it. So I guess Quentos just memorizes or tries to copy on how Claude Mythos responds. If that is what the drummer is saying is true, that it's a scam. Yeah. Oh, one thing yes, that is true. If we want to, this is actually the most common way of using model distillation, is that we want the student model to respond a certain way. So for example, we don't want Qwen3 VL to respond like Qwen3 VL. We want it to respond like Gemini. We can do that by distilling Gemini, and lo and behold, Qwen3 VL responds like Gemini.
One more question that I popped to my mind is that, you know, we are, for example, we are distilling Chinese models to our US models. And we are maybe distilling our US models to our Chinese models. I'm interested whether the values, or maybe that's for a specific example, like for you generated a data set to be fine tuned on the student for a certain use case. But what I'm interested in is actually the values, maybe, or if there's any transfer like US values to Chinese values? Is it even possible? Is it overridable because there are more Chinese models than US models? Or, and vice versa. Like, what are your thoughts on this? Can we transfer over the values of US models to Chinese models that are open source or open based rather?
Okay.
Tell them instead.
Okay. As in regards to that, I guess the Chinese model will learn the US model's biases and values if you try to distill it that way. As in, you try to teach a Chinese model that, uh, yeah, you can actually do that. You can try forcing the Chinese model through distillation to say that, yeah, the West Philippines seating, you can do that. Like, those values and biases, it will only transfer if that's the task in question.
Thank you for that, Jules. And everyone, please feel free to still drop your answers in the chat box, and we're happy to receive them. Anything about model distillation, or anything you'd like to ask about on how and why and when to do these tasks? Okay, I'd like to ask. So, what's been your story in your research on distilling? I believe Gemini to Quen. So you have the first-hand experience. What's been the hardest? What's been the easiest? What are the gotchas that you need to watch out for that you might not have covered earlier? Uh, I'd like to ask those personal things that you encountered.
The most difficult part is actually curating the data set. Like, I understood that we really didn't have time to create a data set from scratch. I mean, we're only working with 4 months. I don't think that's enough to download and scrape and label each video one by one. That'll take hours and hours, and we just don't have the time. So, although the most difficult part is creating the dataset in question, model distillation is what made it faster. So, it was able to fit in 4 months. And gahol pa rin kami nun. So, distillation is a gift from heaven, making our annotations faster. Because if I remember, I'll try to remember it. It was June 6th. That's when we managed to finalize training the model and then deploying it. And then we deployed it on June 8th. And then our defense was, if I recall correctly, it was 14 or 18. So we were rushing everything, the paper and the deployment. So it was really difficult.
Awesome.
Okay.
And I'd like to ask, for your finished work, is it open source? Is there any link that you can provide for us to, like download these models and actually see it for ourselves to share with the community?
Yeah, sure. Here's the data set in question. I'll be honest, it it's going to improve over time. This is just the first version. I guess we can fix and improve some parts. But yeah, it's perfectly accessible. It's there. You can access it.
Thank you.
Okay, there's a previous question, are there any difference in running the inference kapag when in actually on our deployment, VLLM actually performed the best in terms of running the models, VLLM. But that's for cloud deployment, ah. But if you want to run it locally, use Llama CPP or Olama. Olama is just okay, I do agree. Any specific reason why Olama versus VLLM locally? Uh, if I have to say, VLLM works really well for cloud deployment. And if you don't have anything to run on your okay, think of it like this. In cloud, you're only running one thing and that is your model. And when you're running it locally, obviously the model isn't the only thing that you have. You have other applications and programs using your RAM and your hardware. So I guess VLLM is there to maximize everything for itself, and Llama CPP or Olama is just to, okay, we're gonna run it while still sharing resources with other applications. Yes, this is correct. VLLM is for production and concurrent events. Yes, I agree. That's the correct way of saying it. Thank you, Drummer.
Okay, we still have 3 more minutes for questions. So please type them up on the chat box and let's finish strong. If you do have any more, please feel free.
Ah, local llama, my favorite subreddit. Yeah, I've been through that subreddit for an entire month trying to look for tools in deployment and testing. So that's a great starting point for anyone wanting to run low models locally.
Okay, I actually have a question. So you, so for distillation and using the data for fine tuning, you mentioned earlier that let's do human, yeah, like human, what do you call it? Human writing, like human labeling as much as possible compared to distilling from these models, though frontier models. So I'm actually interested. Is there a point where the data distilled from these frontier models is actually more valuable than human data, like human labeled data? Or is the combination of both human, like the combination of generated model generated data plus human verification the best actually the best possible outcome? I want to like do you have any insights on this? Like, is there a point or like is there a point of these frontier model labeled data versus human labeled data where it's better?
Oh, okay. As for that, for that particular question, of English or Tagalog, I try to be as comprehensive and simple as possible. If I'm gonna be honest, AI writes better than me. So in a data set, that's a scenario where the AI beats me. Therefore, using that distilled AI response, I'd choose that AI response over my own writing. But if I am an expert writer and my writing is better than that AI, of course we're going to use the human labeler for that one. That's why there are actually many companies that are trying to look for expert writers in English. In fact, it's an entire industry. Like if you go to Indeed, there are a lot of companies just designed for expert writing. Go to Indeed, go to LinkedIn. There are a lot of positions for that. And I may or may not say that it's a sweatshop, but it's definitely is a sweatshop. Imagine only getting paid 10K a month doing that. I don't think that's a livable wage. That's actually why I did not want to mention my work because that is a depressing kind of work and I feel ashamed about it. I will not mention the company in question as ayokong malintikan.
Okay, another question. Curious, do we still have local LLMs able to run on 16 GB local machine and still able to run the OS?
Yeah, yeah, you can do that. Y- Actually, Drummer mentioned here that you can do quantization techniques. So for my case, wait, let me check my task manager. I want to remember exactly how much VRAM I have. Okay, so I have a dedicated GPU that's 6 gigabytes of video memory. As to when I was running the Qwen3 VL model, I was actually forced to quantize it in Q4 just to run it. Because when I tried to run it using its full precision, my computer crashed. So yeah, you do quantization for that one. Okay. As electrical engineer, should I stick to my field and just mag-study and enhance my workflow or mag-shift career? Deep dive inner workings. Hmm. Ah, I hmm. Should you switch jobs? That's more depends on where you're feeling. Then I guess stick to that. But if you do want to shift careers, you can do that. Mababa pa sa level. Oh. Hmm. Okay, okay. I know an electrical engineer who became a master electrician just to enter a company and do stock, yes, and do 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 stocks. Someone actually did that. Is it ethical? I don't know. But basically, what that electrical engineer did is he entered an electrical company or corporation and started doing stocks there by having an insider. I don't know if it's fine, but yeah, you can do that. Uh, electrical engine. Actually, I do know some people from Cagayan State University who are implementing embedded AI in their own thesis just to check defects in circuits or transformers. So I guess you can try doing that. You can mix your current field with this particular one. Essentially, become a computer engineer.
Okay, may time from drummer. What's the next topic and when? Jules, do you have any planned talk for data engineering Pilipinas that you'd actually like to share with us? Maybe soon, maybe 1 month from now, 2 months from now. Do you have any interesting topics at mind? Thank you for that, Ma'am Fanny. And that wraps up our Q&A. Once again, a big thank you to Jules for sharing his time and expertise with us tonight. And thank you all for joining another AI study group session with Data Engineering Pilipinas. Keep an eye, as mentioned, on our page for the next session. We'd love to see you there. And until then, keep learning, keep building, and good night, everyone. Take care and keep safe for from the typhoon.